Yesterday I showed you the perpendicular bisectors of the triangle. Remember that?
Yeah.
If you've got a triangle, and you will have to do this, make sketches of these. Cole, put your iPad away.
Wait, today?
The only one you got to do today is the very last problem. They have a picture in your book of 3 houses, and they want you to sketch where I forget which one. You're either going to have to do perpendicular bisectors or angle bisectors. So what you're going to want to do in your paper is just make the 3 little houses and connect them into a triangle and then sketch in whichever one it is. So when you do perpendicular bisectors, we're just sketching them. You don't need to use a compass. Just estimate where the center is and then draw as close to a perpendicular line, and then you got to draw the square to show it's perpendicular, and then you got to put that it's bisected, so you got to label 1 and 1. And then on the other one, draw that one in, put that it's 90, and then show that they're equal. And you don't have to do the third one because the third one is going to hit there also, remember?
Yeah.
So the perpendicular bisectors will all 3 intersect at one point. And then remember when we did the construction what I did?
You put that line on each.
You can put a circle. This is the center of the circle, and if you open it up, you can draw a circle around. So this is called all of these that we'll be doing is called the point of concurrency. If you remember from the beginning, concurrent means on the same line. So this point is on all 3 lines. And if it's the perpendicular bisectors, which we're doing here, the point of concurrency is called a circumcenter. And yes, you do need to know that. The reason why is you can, if you put something inside, it's called inscribe, because you're scribing it inside. If you put something around, it's called circumscribe, because you're putting it around it. So that's why this is the circumcenter. You can put a circle around the outside of it. And what this does then is the circumcenter, it's the point that's equidistant from all 3 vertices. And it has to be because the circle is going to go around and touch all 3 of those vertices. So from here to here, here to here, and there to there, they're all the same length. So an example, it's a real short assignment today. If you have a picture like this, and they're the perpendicular bisectors, they'll tell you something like this is 10, and then they'll ask what's the length of this. So you need to know, since it's the perpendicular bisectors, these 3 are all the same length. Now, the perpendicular bisectors, the circumcenter is in a different spot depending on what kind of triangle it is. This is an acute triangle. If it's acute, it's going to be inside, because we would draw the circle around it like that. If it is a right triangle, when you draw these in, that's about the middle there. So then you label that it's bisected. There's about the middle there. And then the third one is going to come right through there. It's going to lie right on the edge of the hypotenuse. And the reason why is you can kind of picture, if you drew a circle around it, you'd put it here, it would come around and touch there, and then just keep going like that. That make sense?
Yeah.
The obtuse one, there would be 1 perpendicular bisector. There would be 2. So the obtuse one is way outside. The third one would be right through there, and they'd intersect there. And you can picture that if you drew a circle, you'd open your compass up to here and bring it down and touch there, and then it'd come way up here. So, perpendicular bisectors, or the circumcenter, it can either be inside, on, or outside the triangle. That's part of your assignment today too, is they ask you where it's at. So it can be all three of those. And then again, what you need to know about that circumcenter, it's the point that's equidistant or the same distance from all three vertices. Then, the other thing we're doing is the angle bisectors. We're going to eventually do this construction also. Not yet, but we will. If you've got a triangle and you drew all the angle bisectors, if I bisected this with the compass, again, when you sketch these, all you got to do is show that that's bisected like that. And then when you bisect this one, you'd have to put two little arcs on there to show that they're equal. And then the third one, these also will intersect at one point. When we do take the test, there is a couple questions where you got to sketch a perpendicular bisector and an angle bisector. Again, the test is a ways away, but you just got to remember to label those. So, on a angle bisector, the point of concurrency where they all intersect is called the incenter. And the reason why it's an incenter is if you took a compass and you put it that as the center, and then you put it to an edge, you can draw a circle that touches all the sides. Here it touches all the vertices. Here the circle's inside the triangle. That's why it's called an incenter. So what you need to know about the incenter is it's the point that's equidistant from all three sides. It's just like the assignment we did yesterday. A perpendicular bisector, every point's equidistant from each point. An angle bisector, every point on it is equidistant from each side. So this one is from the sides, this one is from the vertices. You need to know the difference between those two. Now an angle bisector, or when you draw them, if it's a right triangle, where do you think it'll lie? On it, in it, outside. Now remember, an incenter draws a circle inside the triangle. So it has to be inside, right? When you bisect the angles, remember all you got to do is two of them because the third one will intersect. So right about there would be the incenter on a right triangle. Same thing on an obtuse triangle. If I bisect this one and bisect, that's not right, there, it would be right there. That's not a very good one. It should be more like right about there. One other thing though is when, like I told you on your types of problems, if it's perpendicular bisector, they'll give you this and ask you that. They're all the same. On the angle bisector, when it's the same distance from each side, it has to be at a 90 degree like this. So all three of these distances would be the same. If this is 3, the other two are 3 also. So here they got an example of three boats. The boats are equidistant from a buoy. Do you guys know what a buoy is? Floating it up. So they're wondering, where is the buoy? So if you connected these three boats, forms a triangle. Now you need to figure out, do I got to do the perpendicular bisectors or the angle bisectors? The buoy is equidistant. The boats are equidistant from the buoy. So which one do you do? Perpendicular. Because the buoy is equidistant from three distinct points. So again, this is like your the last question in your assignment. They give you a problem like this. On your paper, you would just have to sketch the three dots, roughly where they are, connect them, and then sketch in perpendicular bisectors. So remember, all you need to do is two of them. So just estimate where the middle is, draw your line in, but then remember to label that it's a 90 and that it's bisected. And then do another one. Label it, show that it's bisected, so right there would be where the buoy is. So on your paper, you do the same thing. You would just sketch in 90, sketch in, show it's perpendicular and bisected. This one looks like it's about a right triangle, but then it would be right there. So here they tell us that the perpendicular bisectors meet at point S, right there. So they want us, if you notice right here, since it's perpendicular bisectors, this line, and this line are all equal. So what is the length of PS? 10. And what's the length of SQ? 10. Okay. Angle bisectors. The angle bisectors meet at point H. So what you need to know about that then is that point is equidistant from each side. So all three of those are equal. What segments are congruent? We just showed MH, HN, HP. So they want us to find HN and HP. They're going to be the same. Now this is where it's a little more advanced. When I draw this in, what kind of figure is that red thing I just drew? It's a right triangle. We know this leg is 24. We know the hypotenuse is 25. They're looking for that. In this book, I wish they did this a little earlier because we haven't done it yet. But remember, on a right triangle, I'll just draw it up here so it's easier to see. This is X, this is 24, this is 25. Anytime you know two sides, you can find a third side in a right triangle by using the Pythagorean theorem. So, the most common ones, you did this in 8th grade, you did it a little bit last year. If it's the two legs, you know, it's just 3 squared plus 4 squared, and then you square root it. That's if it's the two legs, you add them. Here you're looking for a leg, so you remember what you do? Subtract them. So you need to know the difference between those two. If it's the two legs, you square them and add them and then square it. If it's a hypotenuse and leg, you square them and subtract them. So it's 25 squared minus 24 squared, and then you square root it to get X. And I think that's 7. Yep. So HN is 7, HP is 7, and HM is 7. This is one where you got to write an equation. The angle bisectors meet at point W, which means this equals that equals that. We want to find what D is. This length is 2D plus 7, and this length is 4D minus 1. So what do you know about those two? They're equal. 2D plus 7 has to equal 4D minus 1. So you just subtract 2D to get rid of it. Get the minus 1 over here, plus 1. Divide by 2 and you get 4. Now if they actually told you to find the length, you just have to plug it in. 2 times 4 is 8, plus 7 is 15. 4 times 4 is 16, minus 1 is 15. Okay?
Alright.
So, these are the types of problems in your assignment. And then the other part is, it's a circumcenter, sometimes, always, never lie inside the triangle. Those sometimes, always, never problems. So, it's the circumcenter, sometimes inside, always, or never. Sometimes, here it's on, here it's outside. Is the in-center sometimes, always, never inside? Always inside. There's like 3 questions like that.